Alright, in this video we're going to look at the area between two polar curves. And first let's just start by remembering what the formula is. So what we have is, first of all, actually let's just try and think about what's happening here. We're trying to find the area of the shaded region. Let's read the question first. Which expression represents the area of the circular segment inside r equals 4 cosine theta, and above the line r equals cosecant theta? So pretty much find this, the blue area, and there will be options afterwards, but I think we should write it up first. So let's see. If I were to just ignore the purple line, I could get some of this area. Remember, area in polar coordinates comes from getting area of little tiny sectors. So I could, in fact, get this area fairly simply. So it would be all of that shaded. Notice that this is a straight line and it leaves out a little bit of area. It's not the full, like, semicircle looking thing. So I could get that whole entire area if I wanted to. But then, if I look at the purple graph, I could also get this area all the way up to there, again cutting off that part right there. I could get that with just using my formula. So what I'm going to do is I'll get the area of that whole entire red sector that I pointed out. I'll get the area of that, and then I'll subtract off the blue one. So let's see. First, I start out by thinking about my angle that I want to know my limits of integration. This will be for the red spot. Hold on. I want to know the limits of integration, and I think right there it looks like pi over 12, but I just want to make sure. Pi over 12, if I plug it into my equation for r, for the red one, I should get something that is a little less than 4. So let's try that. If I plug in pi over 12, maybe do it in a calculator, you'll see that you get something a little bit less than 4. It's like 3.863 something something something. So that actually looks like pi over 12. And then I'm going all the way. Now, the first time I tried to make this video, I made a mistake because I went all the way to pi over 2. But remember, I pointed out that we're stopping right here, which is actually 5 pi over 12. So the limits of integration are going to be this. And my function is 4 cosine theta. I must square it, and I have my d theta. So it says which expression we're not supposed to evaluate this, so I'm just going to simplify a little bit. I can have 4 squared. Remember, I can distribute this in because I have the multiplication right there. So 4 times 4, that would be squared, is 16, divided by 2 is 8. So I'm going to write an 8 on the outside, and I have cosine squared on the inside. So that represents the area that I showed you, this area right there. So next I'm going to find this area, and it's going to have the same limits of integration. So technically I could put it in the same integral, but maybe not. Well, actually, let's just see. So I am going to subtract off, because remember the red one gives me too much area. I'm going to subtract off pi over 12. The integral from pi over 12 to 5 pi over 12. And I have my other r function, which is r equals cosecant theta. And I square that, and I can't forget the 1/2. I almost did, but I can't forget that. So let's see. Hopefully, I'm just going to double check. Hopefully that's right. Makes sense to me, so I'm going to go ahead and put the answers and see if that is there. So 8 times 5 pi, is that the first one? Cosine squared d theta minus 1/2 pi over 12 to 5 pi. Yep. So the first one works. So that's how you get area between two curves. That's it.